here with Mr. Canada today, and we're looking at inequalities and brackets. So they're in the form, really complicated form at the top, but not so complicated when we start working with it. So we want to isolate x to its own side again, and how do we do this? Well, our strategy is just expand the brackets, and then we're just going to apply the same techniques that we've gone through in the last few videos. So multiplying, dividing, addition, subtraction. Okay, so first off, how do we expand brackets? We don't care that it's inequality. Let's just get rid of the brackets. So we multiply one at a time, the first term outside by the first term in the brackets. So we have get 2x, and then 2 times 3 is 6. Okay, so then on the left side, or I mean on the right side, we get 3x, and then we have 3 times negative 5, which is negative 15. Moving on, we want to see, well, how do we start dealing with this? Well, now we have a mix between multiplication and division, correct? So what we have to do is kind of pick and choose. I typically like getting all my variables onto one side first, so I'm going to do that. Now, I'm going to look at my numbers outside my variables. So if they're both positive, you're going to always, if they're both positive, subtract the negative. Okay? If you happen to do this the wrong way around, don't be worried. At the end, we just have to flip all of the signs. So, but what this looks like is instead of, I'm going to subtract 2x instead of doing with my 3x. So I'm going to subtract 2x from both sides, right? Now, at the very same time, because there's no reason we can't do this in one step, I will show you a little trick how to move forward on example 2 that will really condense the amount of work we have to do. So here, what are we going to get for this first step here? So 2x and negative 2x is 0. And we're just left with 6 on our left-hand side. On our right, we're left with x and minus 15. So now how do we isolate x? Well, opposite of minus 15 is plus 15. So we have to plus 15 on the other side. And we can finally, in the end, write our solved answer as 6 is less than, or sorry, not 6. Forgot to add that. We have 21 is less than x, or we can state that better as x is larger than or greater than 21. Okay, so next example, example 2. First thing we do, get rid of the brackets, right? We don't even care that it looks like a inequality yet. All we care about is that it has brackets and we don't like them. So here, we're going to do 3 times 2x, which is 6x. Then we're going to do 3 times by negative 5. So that is negative 15. Copy the sign, which is a greater than. And then 2 times 2 is 4. 2 times negative 4 is negative 8. And then we have this x. So let's look at our variables. So we have 6x and negative 8x. So if we move that 6 to the right, it'll become more negative. So let's move this 8x to the left. That way we have positive x in the end. So positive 8x, we'll make that 0. So we have to plus 8x on our left. Similarly, we want to move all our numbers to the right. So I kind of said in the last example and then stopped myself that I was going to show you a little trick to how to do this all together. Because in the end, I've mentioned before, we are really just looking at a column at a time, right? So we're looking at all these different columns and then just working them down one at a time as kind of an equals. So here we have negative 15, but we want to move it over to the other side, so we have to plus 15 here. Here, we don't touch anything with the operator, or the inequality sign. But then we have this 4, right? So we have this 4 and this minus 8x. What do we have to do this for? Well, here's where we have to add that 15 as well. So in the end, and I wouldn't advise drawing those columns because it can make it a little bit messy and confusing. So here, 6x and 8x, we're going to get 14x. That's going to take care, this whole thing is going to be gone. If we look on our right, we can do the same thing. That whole thing's going to be gone. And we have 4 and 15, which is 19. So this isn't actually going to work out too nicely, but that doesn't matter to us because we're just going to leave our answer as a fraction. So how do we simplify this even more? Well, we get rid of the number outside of our x because we want to isolate it. So in the end, we can leave our answer as x is greater than 19 over 14. And example 3, what happens when you have a mix of some brackets, just some random constants, some other another variable just stuck in there? Well, this is going to be a mixture of expand and simplify and then solve. So let's get to it. So here, getting rid of our brackets, we have 2 times 3 is 6. Then looking at our next term here, 2 times negative 2 is negative 4. And this x, don't forget that. And then we're stuck with this negative 4 over here. Then less than or equal. 3 times 4 is 12. 3 times negative x is negative 3x. Then we have add 2x. And then we have to take away 3. So before we actually start moving stuff around, I want to simplify. Because the more we can simplify, the less stuff we're going to have to actually take away or divide, add, etc. So on the left-hand side, let's look at this. We have 6 and negative 4. Well, we know we can write 6 and negative 4 together as simply 2. So we have 2 minus 4x on our left. On our right, what do we have? Well, we have 12 and negative 3. So that's going to be 9. And then we have this minus 3 and plus 2. Minus 3 plus 2 is minus 1x or minus x. Okay. And now this looks like something more manageable that we've dealt with before. So I'm going to move my x over. So I always start with my variable. That way I can designate which side is going to make it positive, or try to at least. So add 4x, and I can add 4x over here because I can see at the end I'll have 3x. So now we know we got to move get rid of our numbers on our right side. So I'm going to subtract off this 9, and therefore on the left I'll subtract 9 from that side. So on the left hand side, we can cross out the 4x's. On the right hand side, we can cross out the 9's. So we're left with 2 minus 9, which is minus 7, or negative 7, and that's less than or equal to, well, negative x plus 3x, or 4x, is 3x. So we actually have to do one more step and divide both sides by our numerator, or the coefficient in our numerator. So in the end, we can leave this one again as negative 7/3 is less than or equal to x, or x is greater than or equal to negative 7/3. So here's 5 questions of varying difficulty for you to give a try. So pause the video now. Once you're ready, press play, and I'll go through the answers with you. Okay, so I'm going to kind of expand all the brackets just below each one, and then we'll work on kind of solving for our x. So here, we're going to get 2x plus 2 is less than x minus 3. Here we'll get 3x minus 6 is greater than 2x plus 2. Next one, we get 4x minus 6 is greater than or equal to 10x plus 15. Then we have 12x minus 12 is less than or equal to negative 4x plus 2. Watch out for those signs on the negative outside of your bracket. And last one, we have 2x minus 4 is greater than negative 4x plus 2 plus 2x minus 4 plus x minus 2. So the last one's going to be a little bit of a doozy, it looks like, but it won't. It'll be one step and then it'll look like the rest. So let's get down and work with these. So I'm actually just going to write them, change that first one to be up here so I can have a little bit of working room, because I'd rather show all the steps if I can. So here, what are we going to do? We want to subtract x. That way we'll just have a single x over there. So that means we have to, left side we have to get rid of this 2, and right side we'll get rid of that 2. This will leave our end answer as, I'll actually do it in green. Our end answer is going to be x is less than negative 5. Moving on, writing this one up here, so 3x minus 6 is greater than 2x plus 2. So what are we going to do to move stuff around? Well, I'm going to take away 2x from the right. So on the left, I'll be left with just x once I subtract. So that means I have to get rid of this 6, this negative 6 on the left. So we add it to the right. And in the end, we're going to be left with x is greater than 8. Next one, we have 4x minus 6 is greater than or equal to 10x plus 15. So, same thing, look to how we're going to keep our x positive. Well, that only happens if we subtract 4x from that side. So we have to subtract 4x from this side. That means we want to move this plus 15 to the other side. So we have to subtract it from the right. So we subtract it from the left, leaving us with negative, whoops, it should be in green, negative 21 is greater than or equal to 6x. So x is less than or equal to negative 21 divided by 6. Because don't forget, this had to be divided by 6, divide by 6, and then I just switch the signs. Or switch the sides, not the signs. Alrighty, 2 more to go. So here we have 12x minus 12 is less than or equal to negative 4x plus 2. Okay, so moving this negative 4 to the left will keep it all positive, or keep the x's positive. That means I have to move this negative 12 to the right. So, combining these together, what are we going to get? Well, 12x and 4x is 6x. And then we have less than or equal to 14. So once again, we're going to divide both sides by 6. And we'll get x is less than or equal to 14 over 6, which is 14 over 6. You could also see that as 2 1/3 or 2.3 recurring, right? But completely fine to leave them as fractions for the time being. Last one, since it's a little large, I'm going to scroll down a bit and go through it down here. So our first step, I want to start collecting our like terms. On our right side or left side, we can't really simplify that any more than it is. But our right side, I'm going to underline in red, all the terms that are simply numbers and their operator to the left side. So I want to collect those. Similarly, I'm going to underline in green anything that has an x and the operator to the left. So then I'm just going to do this while I rewrite. So x occurs first. So if I have negative 4x and I add 2x, that's going to leave me at negative 2x. Then I add an x. There, I'm at negative x for all that on the right side. Similarly, in red, I have 2, and I take away 4. So now I'm at negative 2. And then I go negative 2, and I take away another negative 2. Or take away 2. I'm at negative 4 now. So really quick, that actually becomes something kind of nice. So, how can I simplify this? Well, let's take a look. Same thing. Well, let's move this negative x to the left to make that a positive. And move that over. And then we'll have to move this negative 4 to the other side. Well, how do we do that? We have to add 4. So we add 4 over here. Very end, we're going to find that we get our total answer as 3x is greater than, well, that's 0. So, well, if 3x is greater than 0, then 1x also has to be greater than 0.